Hello, everybody. How's things going? I'm here. Okay, who's here? That's the question. So here's the assignment for today. You have to, if you're here, say something now. Jimmy's here. If you're here, say something now. If you are not here, you got to post in the comments that you have watched the video. Okay? So if you're so I just want to keep track, make sure everybody's doing okay getting on the video. Deja's here. Right? Eric, picking on Jimmy already. Let's see. Deja's here. Ryan's here. If you're here, say something now. And we'll start with a few problems, and then we'll talk about we got some information about finals, get information about grades, so we could talk through that. If you know someone who should be here, just give them a call right now and tell them to get here, because we got some grades, we got some finals, we got some senior information to convey to you. But let's first work on a few problems. Let's start with this one that I posted up here, number 22. Remember, you could, if you're you could be on AP Central, or I put the PDF copies online. So take a look at those. So what we got here is this first one. Here, I'll put it up underneath here. Okay, it's in there. This first one, let me change to scenes here. This first one here, this is a good one. This is a tough one. This is a separation of variables one. You got to recognize this. Okay, I got some AP information also. We'll talk through. Okay, if you could recognize this, you got to look through this right now and go, this number 22. Everybody find your work that you did on number 22. All right, we got dy dx is equal to 2y over 2x plus 1. Okay? And you got to recognize this as a separation of variables. You got the initial condition, y of 0 equals e, and then we have x is greater than negative 1/2. Remember, they never give you extra information, so we're going to use that at some point in time. Okay, so how do we separate variables? Okay, your binder should be right open to separation of variables. Okay, because here's a little information I found out about the AP. Probably, and we'll have the official by the end of the week, but probably it's going to be open notes. Okay, they just can't, especially if they're administering the AP tests at home, they cannot, prevent you from using notes. So probably it's going to be open notes. So here's where your binder is coming right in. Okay, so as we do, fill in the binder. If there is a separation of variables problem on the binder, that instead of, it's probably going to be timed also. So you're not going to have time to flip around, look online for example problems and stuff. So you flip right over to your binder, 5 seconds that we've been practicing. Flip over to your binder to separation of variables. Take a look. So we got to put all the x's on one side, all the y's on the other. It should say right there in your binder that you cannot add or subtract. You got to multiply and divide. It should say right there. So what I'm going to do is I'm going to get the x's on this side. Remember, we cross multiply. So I'm going to leave the 2 right there. Let me just take that extra step. 2x plus 1 dx. And then I'm going to leave the dy over there. You see, there's the first one. Get rid, put all, x's are going to be on the right side. The y's are going to be on the left side. Okay, so now I got to get this y, and again, I'm going to divide by y. So I got 1 over y, dy is equal to 2 over 2x plus 1. I could have moved the 2 there, but I'm just going to leave it on that side. You should call your counselor there, Jimmy, and see how I'm sure they got to have some type of provision for that. You should email right away. There's nothing official has been said on the AP test. That's supposed to come down April 3rd, but I would say yes. I would say you should pursue that. Okay, so we got all the y's on one side. We got all the x's on the other side. You see that? And we're going to integrate now. Separation of variables is first step. This should be right there in your binder. Separation of variables, step 1. Now you integrate. Integrate each side separately. So if we're working on that side, okay, the integral of 1 over y dy, natural log, absolute value of y. Okay, now this side, how are we going to integrate that? Okay. First one gets a bonus, whoever says it in chat. How do we integrate that side? Oh, wait, you get a bonus. We got only three ways to integrate. What would you do? No one's saying it. Natural log. But, when you're thinking natural log, that's correct. But every time you think natural log, is it fundamental theorem, algebra, or U substitution? When you think natural log on that side. Anytime you think natural log, you got to say U substitution. Okay, U is equal to 2x plus 1. That's what's on the bottom. Okay. You see that? It's got to be du, dx. And there is chain rule there. That's the biggest mistake that people make. Okay, and there's going to be, if they do one of these, because remember, they don't have area volume. So I'm really thinking one of the AP problems is going to be a separation of variables problem. Okay, so here, dx is equal to du over 2. We're doing U substitution right here. So let's see. We got the integral, 2. There's my u, du over 2. And look at that, the 2's cancel. So, natural log, absolute value of y. The integral of 1 over u du. So that's why we have natural log, absolute value of y equals natural log, absolute value of our u plus c. Check your paper. Did you get that far? This is a tough one. Okay, take your time on this. Get it right. How's it looking so far? We'll go through the whole thing. You can ask some questions here. Okay, so now we want to solve for that c. We plug in our initial condition. When x is equal to 0, y is equal to e. This is no calculator. So we put an e right there. Natural log 2 times 0 plus 1 plus c. So we got natural log of 1 plus c. We got natural log of e. And take a look. 1 equals c. You found the c. Okay, now if the 2 was on the other side, if you move that 2 there, then both sides would have to have U substitution on them. Because this is, if we did, let me change colors here. If this 2 went over here, you got 1/2 out there, and you'd have a 1 up there. You see that? So this would be 1/2. This still would have the 1/2 on this side because it wouldn't have canceled with that 2, and now the 1/2 would cancel. So you'd still be, you should wind up at this stage, you'd be at this stage, the same thing. So now, notice we still don't know which problem it is. So we have, let me put it up here, we have natural log of absolute value of y. We'll deal with this absolute value now. Natural log absolute value of 2x plus 1 plus 1. There's our c. Our c is plus 1. Okay? Okay, so now let's talk about the x is greater than negative 1/2. The reason why they said that is right here. If x is greater than negative 1/2, this is always positive. So we really don't need the absolute value on this one. Because when I plug in, for example, I plug in the initial condition here. When I plug in, let me show that. We really don't need the absolute value 2x plus 1 plus 1. When we e both sides, we'll deal with this absolute value of y in a second. But notice what happens here. Now here comes the part that people are going to mess up. Remember the rule for e. I'll show that step. E, when its exponents are adding, it's times. This, remember that, that's the part that people are going to get all confused at. Be ready for that. It's times. When the exponents are adding, the rule was adding exponents changes it to times. Now these can cancel. I get absolute value of y, 2x plus 1. Hopefully you're like, oh, well, that's b. But if you want to deal with the absolute value, remember I plug in the initial condition 0. I better get positive e. I don't need that absolute value then. And there is B. And like I said, that's a tough one. That's a difficult problem to do. All right, how do we feel on that one? Did that everybody get their question answered? Everybody feel okay there? Because I could go over the most missed ones, but still. Okay, that one was a lot of people, be careful there. All right, people were posting which ones they were stuck on yesterday. Now remember, your assignment today, okay, you have to, if you're here now, take a look at what I marked down. If I missed your name, take a look at, I marked down who was here. And if you're not on this list, say something now in chat, or, post in the comments to say you've watched the whole video. Okay. But the people that are here, ask me which problems you want to do. I know which ones people got wrong, but if there's some that you want to focus on, we can focus on those right now. I'll take a look. Anybody got one? There's a couple. There's plenty I want to go over. But say one that you got wrong. I would say it's easier if you just do the PDF. If you just work through the PDF, print it out, work on the PDF, because that lockdown is not as stable. So some people are having success with it, but when it locks it down and then it freezes your iPad for a few hours, that's not as good. All right, here while people are finding, just list in the chat which ones you want to go over. One, there's probably going to be no finals. I would say 99%. The board has to approve it. We're not going to have finals. Okay, so Rayan, lucky you. He's not even here right now. But yeah, so I would say there's not going to be any finals. So you don't have to worry about that. Grades, I would say the grade you have now, I updated grades, I put everything that people were missing in. Take a look at your grade on Infinite Campus, and the grade you have now is probably the grade that you're going to be posted. Probably the grade, because here I'm just checking in, making sure people check in, making sure people are doing okay. So I wouldn't worry about grades, but we've been saying that all along. Remember, okay, it's all about you now. It really is. You have to have that character. You have to have that desire to want to prepare yourself for the AP test, because the governor already said, you probably heard it on the news, we're at least no school till the 30th, and the AP test is the next week. So we're probably not going to be back to face-to-face to do AP review. We're probably going to be doing this AP review in the mornings every time. And so, yeah, you could set your alarm you could sleep late and screw around, but this is on you now. This is completely, get your binder and have a nice space to work every day at this time, and then do the problems that I give you. And as I find out more about AP, the type of problems they're going to be doing, we're going to be practicing more of those. But it's really that. It's really on you, so keep that in mind. Okay, I can't just force you. I can't find you walking the halls and telling you, hey, come to class. Okay, so probably no finals. Probably we will be reviewing until AP test. Whenever that particular AP test is, we'll probably be reviewing all the way. Okay, so you try to make your best effort to get here at 8:30 to get your questions answered, and then work on it during the day to make sure you're doing okay. Make sure, and don't let any holes. Have your binder ready to go. That's how it's going to look. All right, let's go number 30. Two people wanted to do number 30. Okay, so let me put the problem here. Here's number 30. Okay, and notice the key words there is a Riemann sum. Okay, they're talking about a right Riemann sum, approximation. Let's just review what a Riemann sum is again. When we were first talking about the rectangles, let me just draw a picture here. Here's our area, and we had a bunch of areas. The actual area was adding a bunch of base times heights, right? Plus base times heights. Base times heights, right? We're adding a bunch of rectangles. Well, they said 5 rectangles, 10 rectangles. we had a little symbol for that. Oh, let me change that. The area is approximately. And then we said the area, here's our bunch of rectangles. You get the idea. That's where we were. And then we said a little symbol. The area is approximately the summation of all our base times heights, right? Okay, just adding up all those rectangles. Okay, now here it comes. The area is equal if we take the limit as the number of rectangles approach infinity of this summation of our base times heights. And we could have used the right side to make the rectangles, left side, whatever. But we have to, that's the key. That produced the integral of our blah, 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 dx or dy. That's produced the integral. This red here is this red integral. That's the notation. That summation, the limit of that summation. Okay? That's the key to this problem. When you're doing a Riemann sum, remember, we're adding up all those rectangles. So on this problem, they said the Riemann sum is equal to, when I add up all the rectangles, you see, the right Riemann sum with n rectangles, subdivisions, rectangles, is equal to this. Okay, so they're saying this part right here, let me box it, this summation here is equal to 2 parentheses n plus 1, 3n plus 2 over n squared. They're saying my right Riemann sum formula, now usually we just add up the rectangles together. But they're saying in this problem, they made a formula out of that. For example, if there's 2 rectangles, I plug in n is equal to 2, and I get my approximation for this area. If there's 5 rectangles, n is equal to 5, and I get my approximation. That's where they're saying this formula is. So as you're reading through this, you got to recognize that this equation is saying the right Riemann sum with n subintervals is equal to this. You got to recognize that this is telling you what the Riemann sum formula is, as opposed to us just brute forcing our way and adding a bunch of rectangles together. Just say that equation is the formula. Okay, so notice to get the integral, we take the limit as n approaches infinity of that formula. And I'm looking at that formula. We had a nice little way to take a limit, top heavy, bottom heavy, even Steven. Notice this is even Steven. Okay, so what does it come out to? If I FOIL this, just worrying about the n's, I got 6n squared on top with a bunch of other stuff. I got n squared on the bottom, so this limit is 6. So therefore, the integral from 0 to 2 of f of x dx is equal to 6. That's the idea on that problem. Now let me talk through it one more time while you're digesting all that stuff. Okay, a Riemann sum is a summation of a bunch of rectangles. That's the symbol we say for summation. Okay, when we take a limit of that summation, we get the actual integral. This first 3 lines is the Riemann process. That's always the same. That never changes. We're used to not going to infinity. The AP problems, like for data and stuff, say, oh, look, do 4 rectangles or do 2 rectangles. Well, they're saying, though, this is the formula for the Riemann sum. That's what you got to get out of the problem. Okay? Out of the problem, you say, this is the formula for the Riemann sum. So all you have to do is take the limit of that formula to get what the actual integral is. And it's even Steven because if I FOIL this top out, if I multiply it all, I get, let's send it in, take that extra step. Let me change colors here. If I FOIL that out, I get 2n plus 2 times 3n plus 2 on top. I do it again. I get 6n squared plus, 4n plus 10n plus 4 all over n squared. That's what this part is all FOILed out to be. Notice 6n squared over n squared. Oh, I'm getting n cubed. 6n cubed with that 2 in front. So that limit, even Steven, is equal to 6. Which means the integral is 6, because the integral is the limit of the Riemann sums. Deja, you asked about that. Hunter, what do you think about that? Did that make sense? Do you see the process of how we're going through it? And then really you just have to recognize that you got to take the limit. The distractions are plugging in 2. That fact of that 2 means nothing. You don't plug in 2. The fact is 0. You don't plug in 0. It's the limit of whatever a Riemann sum is equal to as I go to infinity. All right, how about number 8 and 9? I don't want to say one number over the other because then Jimmy and Eric will fight for an hour online. These can't hit each other now. Yes. Now remember, if they say give me an approximation of this Riemann sum using 4 rectangles or using 3 subdivisions or using 2 subdivisions, then you do the approximation. But if they want you to find the actual integral, okay, like this problem says, what's the actual integral? You got to go to infinity. Is that okay? All right, let's try the next one. Let's try another one here. Let's do number 8. Okay, we got a function. Okay, and which is following with tangent lines. 8's talking about a tangent line. We got a function, f of x is equal to e to the x over 3. And we want a tangent line. What do we need for a tangent line? They gave us a point, 3 natural log of 4, comma 4. Okay, so the first thing we got to do for a tangent line is we need a point. We need the slope. Okay, so here's our point. That was kind of easy. First of all, can everybody see that when I plug in 3 natural log of 4, let's just show that. 3 natural log of 4 over 3. The 3's canceled. E's and natural logs now cancel. And we got 4. There's the point. So really this problem is I just need the slope. This is number 8. The slope is the derivative. I look at that derivative and right away I see chain rule. Don't forget about chain rule. That's where a distraction comes in. E to the keep times the chain rule. And you got to recognize it's just a fraction. It's just 1/3. Okay? And so we plug in the point, 3 natural log of 4, as we just talked about. 3 natural log of 4 over 3 times 1/3. Cancel, cancel. Cancel, cancel. We got 4 times 1/3. We got 4/3. Okay, look at your distractors. Okay, where was the distraction? Okay, first of all, a slope of 4. You forgot the chain rule. Oops, sorry. If you said B or D, if you got a slope of 4, you forgot putting the chain rule in there. Okay? And then the difference between B and D is people put the Y with the X and the X with the Y. The only one that has a slope of 4/3 is A, so this answer must be A. Number 8. How's that? Eric, your problem? Did that make sense? And while he's thinking about that, let's do number... I did notice there's a little time delay. Okay, so it'll take a little bit. I was looking at the countdown clock and then looking at the YouTube live online, and I got about a 10-second delay here. So I will wait for you. Or if you just say something, you can always say something to Chad. You guys never worried about interrupting me or anything like that. All right, let's take a look at this graph. Okay, take a look at the graph here. This is number 9. Okay, Jimmy was talking about number 9. We got the graph of the function, which the following is the integral. Let's look at each one of them. And it's about greater than or less than. As soon as I see greater than or less than, I'm thinking positives and negatives. Okay? So what about the integral from 0 to 2? What do you think about that? 0 to 2. Is it positive, negative, or 0? Remember, when you can't find the actual answer, you think to yourself positives, negatives, or 0. Okay? When you can't see what the actual answer is. Okay, from 0 to 2, positive. It's above the x-axis. Okay, what about the integral from 2 to 3? Integral from 2 to 3 is negative. You see that? So right away in this problem, I'm thinking, I know the integral from 0 to 2 is positive. I know the integral from 2 to 3 is negative. So right away, it has to be starting with 2 to 3. So it's got to be C or D. And it's got to end with the integral from 0 to 2. Right? So it has to be D. You see how I thought through that? I know from 0 to 2 is positive. I know from 2 to 3 negative. So right away, I know the integral from 2 to 3 is less than the integral from 0 to 2. Because this one's negative and this one's positive. So it can't be A. It can't be B. Maybe C. Because that's less than that. And maybe D. Okay, so let's take a look at comparison. Okay, so now let's look at the integral, the entire integral from 0 to 3. Now, since I know that is positive and that's negative, the entire area, 0 to 2 is big, and then now I start subtracting stuff off. So of this area, the area from the entire area, 0 to 3, has got to be less than from 0 to 2. It's still positive because that positive area is bigger than the negative area. So it's still positive, but since I'm have this whole area here and I subtract off this little part, maybe I could eyeball it and say, yeah, maybe this area is the same as this area. I subtract off a little bit from the bigger part, so that's why 0 to 3 is less than 0 to 2, because I'm removing stuff from it. You see what I mean? And so now it's still positive, so that's why I squeeze that 0 to 3 in the middle, and that's why the answer is D right there. What do we think about that? Everybody see an idea there? All right. Anybody else post one? There's a couple I still want to talk about. Anybody have another one they just want to have a discussion about? That those are online right now. Because let's do, hold on, let's find, I think we did, oh yeah, like those area ones you're talking about, or the Riemann Sum ones. Yeah, I was going to 28, okay, and I was going to 29 also. Let's look at 28 and 29 here, okay? Take a look at 28 and 29. And 7, okay, write that down. 28, 29, 7. Look at this page right here, 28 and 29. All right, the isosceles right triangle. Okay, so first of all, everybody find, okay, did you recognize 28? Isosceles right triangle, the area of the triangle is increasing at a rate of, okay, the hypotenuse of the triangle is increasing. Right away, did you recognize number 28 is a related rate? Okay, so if you're following along in your binder, which you should be, okay, 28 is a related rate problem. It gave us the area. Wait, let me draw a picture here. We have an isosceles right triangle. There's the sides. And that area is 1/2 s squared. Now here's how I know it's a related rate problem. Okay, so I'm reading through the problem. It says the instant when s is equal to square root of 32, okay, the area is increasing at a rate of, as soon as I see that increasing at a rate of, dA dt, the area is increasing at a rate of. And that is, was it 12? And then I keep reading. It says at what the length of the hypotenuse of the triangle is increasing. I want, okay, dH dt. And there's the hypotenuse right there. You see that? That's how I know it's a related rate problem. It has area. Well, okay, so what? But then it has dA dt and dH dt. The question is about dH dt. It's given us dA dt. Okay, so we need an equation that has h in it. And hopefully you're looking at it and you're going, oh, isosceles right triangle. The equation is h is equal to s square root of 2. For a right triangle, for isosceles right triangle, s square root of 2 right there. We could have done Pythagorean theorem also and said s squared plus s squared is equal to h squared, and it will simplify to h is equal to s square root of 2. Why do we need a formula for h? Because the question's asking for dh dt. Okay, so I say dh dt, I take the derivative, dh dt. This is just linear, is square root of 2 times ds dt. All right. Oh, I don't have ds dt right here. All right, so I need another equation. I would love ds dt, but I have dA dt. Okay, how do I find ds dt? Well, they gave me this equation right up here, so let me try that one. dA dt, and here's a little power rule, is equal to 1/2 times 2s times ds dt again. Again, here's the related rates, the implicit differentiation, the chain rule. Don't forget about each one of those parts right there. Cancel here. Let's plug it in. 12 is equal to 2. Oh, don't cancel the s, cancel the 2's. 2 square root of 32 times ds dt. Plug in for the s. S was square root of 32. dA dt, they said was 12. Look, I could figure out what ds dt is. ds dt. Oh, wait, hold on. I cancel the 2's. The 1/2 and the 2 cancel. I got s. So ds dt is equal to 12 divided by square root of 32, whatever that is. Okay? All right, let's back it up. Well, let's finish the problem first. So now I just plug in ds dt, dh dt. We'll talk about it again in a second. Is equal to 12 over square root of 32. No calculator, so I cancel that by hand. 12 over square root of 16. And so square root of 16 is 4. 12 divided by 4 is 3. The answer is B. Let me change colors here. All right, let's work from the beginning. First part. It said an isosceles right triangle with leg equal to S. So I drew myself an isosceles right triangle with leg equal to S. It has an area of that. Okay, I did not have H in there yet. I just said, okay, there's an isosceles right triangle, and there's the area. Now I keep reading. They gave me the side. It says when the side is equal to square root of 32, so I put square root of 32 right there. The rate of change of area. So right away I recognize that rate of change of area is dA dt. Rate of change of area is equal to 12. And I keep reading, what is the rate of change of hypotenuse? So the question is asking for dH dt. So as soon as they ask me that, I got to say, well, let me put a letter. H is the hypotenuse. I put that in my picture also. So right here is just grabbing the information from the problem. So let's make sure you're good with that. As you're reading, as you're translating the math, the English to the math, all this information was given to me in the problem. Okay, so that first equation was given to me. Okay, so now I got to say, all right, well, how can I get an equation? I want dH dt right there. So I say, well, I need an equation with h in it. The hypotenuse, I could have done s squared plus s squared equals h squared. I could have done Pythagorean theorem, but which would simplify completely to a nice little shortcut equation. Remember, for our 45-45-90 triangle, x squared root of 2. So h is equal to, if I wrote that down, s square root of 2. H is equal to s square root of 2 right there from a 45-45-90 triangle. There's that equation. And if you notice, if you just did Pythagorean theorem, s squared plus s squared is equal to h squared. I got 2s squared is equal to h squared. Square root. H is equal to square root of 2 times s. Exactly what we said right there. So I took the derivative. dH dt is equal to, this is linear, so square root of 2 times ds dt. Oh, I didn't know what ds dt was, so here's where I need another equation. Okay, so I'd use the area equation. And then I go, okay, dA dt is equal to S ds dt. Again, related rates. You always got to have that ds dt. It's always chain rule. Plugged in the information, I found ds dt. Plug in ds dt into this equation, and I found dH dt. Can everybody follow that? Did that make sense to everybody? Let me know if you're still stuck on that. Are we good? Eric? Remember, you can always pause the video if you're looking at this later and then try it on your own. And then Jimmy wanted to do number 7. Okay, let's take a look at number 7 here. How you got? Oh wait, how you got the answer 3? Let me. Are you okay that how I got ds dt is equal to 12 over square root of 32? Because I took the derivative of this one. Put that in there. I took the derivative of this one. dA dt is equal to, drop the power down, the 1/2 cancels with the 2. dA dt is equal to S ds dt. So I plugged in. 12 was given me there. That was given me there. So ds dt is 12 divided by that. Okay, so now I go here and I plug in that. 12 divided by square root of 32. Now I have no calculator. So the square roots got to cancel with each other. So I got square root of 2, square root of 32. Take off a 2. I got square root of 16 left. No, square root of 16 is 4. So 12 over 4, we got 3. Let's do number 7. Okay, take a look at number 7 here. All right, let's see what we got here. Now, here's one of those ones where a picture might really help us. I have the integral, let me just draw a picture, from 4 to negative 10. Oh, wait a minute, 4 to negative 10. I cannot say that. I cannot do 4 to negative 10. Here's negative 10. Here's 4. I have the integral, whatever it looks like, but right away I'm changing to the integral from negative 10 to 4 of g of x dx is equal to negative 3. Remember, I'm flipping it around. I always want to go from smaller to bigger. And the rule was to switch from smaller to bigger. We flip it over. Okay? So we know that area here from here to here is 3. Whether it goes underneath, whatever it does is 3. So now they said the integral from 4 to 6. Okay, see how a picture is going to help me here. The integral from 4 to 6, well, that's kind of straightforward, is 5. So what's the integral from negative 10 to 6? The answer is D. So what was the key on this problem? The first thing is, as soon as you see 4 to negative 10, you say, I got to flip that over. I got to change the sign. Okay, I got to go, all right, it's positive. Maybe a picture might help. But you can't go, when you can't go from 4 to negative 10 to 4. So you got to flip that over. You got positive 3 there. This one's straightforward. It said it was 5. What's the integral from negative 10 to 6? It's 8. Okay, how are we feeling here? We're almost done here. Let's do this. Okay, so first of all, take a look here. Let's just cover our bases here. Okay, first thing is, if you do not see your name on the list and you came here late, let me know. Today's assignment is you have to either tell me now that you're here or post in chat. I will check in chat this evening. Post in chat and say, Mr. No, I watched the whole video or whatever. Just say which numbers you want to work on. I got to make sure you're with me here. Okay? So, second, finals, I would believe finals are not going to happen, so we don't have to worry about finals. And I would say the grades are what they are. The grades aren't going to change. Okay, really, I personally am just doing participation grades here. So if I'll put stuff, they want us to put stuff in the grade book, but I'm going to mark those as not for grade. And that's like for today's assignment. Like yesterday's assignment, I'm marking down who said something and posted some problems that they want to do. Today's assignment, I'm marking down who has watched the video. Okay, so it's really just participation grades. And like I said, you could lie and cheat your way through stuff, but it's all about character. Okay, it's all about you're working for the AP test. So I'll find out more about the AP test coming up this week. There's a big meetings and stuff, and we'll just keep practicing some problems. Once I find more about how the AP test is going to go, we'll practice more types of problems. Okay? So let's try to finish. If there's still some no calculator ones that you don't get, we're going to work on those. Okay? And post them in the chat or send them on Schoology or something like that. And say we still got to work on these problems. And then start working on the with calculator ones. Okay, the with calculator ones on use the PDF. You don't have to worry about although some people did it already. Even if you did it on lockdown, that's fine. Okay, so start working on the PDF ones, and then we're going to go over those. Okay, and I will see you tomorrow. Okay, so hopefully everybody is doing well at home. Hopefully everybody's getting their work done and stuff like that. And if you are watching this later, okay, say hi and write down. I want to know which ones we should work on tomorrow. Okay? But everybody has to check in, so make sure you check in here. Everybody good? It's use the PDF. Okay, it won't unlock. And then, like I said, I've been having some problems with so we can see what we got wrong. The answers on the PDF. Okay, let me see. Hold on, let's see if I can do that. So can I? It's not. It doesn't say it's locked to me. Hold on here. Let's look at take a look at what I see. So here's the test that you took. Oh, hold on. I got to re-enter my password. Don't look at my password. All right, let's see what it says. Here's the test that you took. Oh, that's the actual test. Hold on. They want me to sign it. So let's go to the assign part. Progress. All right, you're in the lockdown browser. This is the one that was due. And it says it's unlocked. Students see results. It says you could see the results. Let me just see if I could settings. All right, let's see. Okay. Unlock the assignment. Hold on, wait. Not a printer copy. Unlock the assignment now. Use secure. It's got to use secure browser. That's just how they have it. So you'll have to look at it inside there. And I'll just leave it. Let students see the results? That's there. All right, let's see if that's locked out. Somebody go in and check it. Yeah, somebody go in there and see if you could see. Can you take a look now? Let's see. That should work. I'll wait. Yeah. Can anybody get access to it now? Yeah, it looks like. Well, see, and if you're not sure, the answers are in on the PDF. So if you go past, the PDF, the questions, the answer choices are there. If you want to send me an email, I could put in, I could probably see which ones you got wrong. If anybody is still can't get it, or it locks your computer or something like that, I could probably take a look at which ones. Yeah, I could see which ones that you got wrong. I could see your score. I wonder if I could send your score out. Yeah, I could see your score. So if you can't figure it out, if you can't get through and you can't see the ones that you got wrong, just send me a message. I'll be around all day. I don't go anywhere or do anything. So I'll be around all day. So you can send me a message and I'll tell you which ones you got wrong and which ones you should work on. Okay? All right, I'm going to go start the other class, so I will see you guys tomorrow, same time. Call your friends and tell them to get online. Okay, and like I said, if you can't figure it out, just send me a message. I'll send you what your grades were or which ones you got wrong. Okay? Talk to you later.